we're just going to look at climate graphs and how to analyze climate graphs. Now, you'll notice this is a climate graph, and you can read this over here by yourself, but you'll notice it has two things. It has this line, a line graph, which is the temperature, and it has a bar graph, which deals with the rainfall. Why might this be important? If we look down here, this type of data set is useful for climatologists, obviously, but also for tourist operators because they want to know when to do things at different times of year. Farmers, for the obvious reasons, when to plant, when the best growing, when their best rainfall might be, or too much rain not to plant, things like that. Obviously, holiday makers, and then government industry on when to do things like building infrastructure. If there's too much rain, they're going to have too many days out. So it's a really important graph, which many people use for different purposes. So here's a quick look at it again. Temperature can be seen running on this line, and it's down one axis. The months of the year are along the bottom, and that's indicative of the temperature in any month or the rainfall in any month. And the other axis over here deals with the precipitation or rainfall. So millimeters and degrees Celsius. And then along the bottom, months of the year. Now, how do we analyze them? Let's have a look. If we look at these three here, we've got 1, 2, 3, with three different biomes, all relevant to Australia. Okay, we start with the desert biome in Alice Springs, which is here in the center of Australia. You can see that, like this dip trend in the middle of the year. Now, that's always indicative of a southern hemisphere place. So if it was a northern hemisphere, we'd probably expect the opposite of this, because we have winter in the middle of the year. They have winter at the end of the year. Okay, so it's indicative of a southern hemisphere. The range of temperature, if we look at the temperature range, it's quite great in this desert biome. It starts in January around 30 degrees and goes down to as low as in June, July, or in June to 13 degrees. So to do the range, we take one away from the other. So 30 minus 13, easy sums, and it gives us the range, which is quite big, right? The next thing is the driest month is in the coolest month. So you'll see a relationship between the driest month, with rainfall down the bottom, is in August, July and June, this period here, which is also its coolest month. So winter and rainfall have a relationship whereby there isn't much, and summer and rainfall is where there's more in this place. So it's wettest in the hottest months of the year, or the summer months. Let's jump over to Cairns now, where we have a tropical rainforest biome. So how would we write this analysis up? Again, its temperature is indicative of a southern hemisphere. The temperature range is from 26 degrees through to about 20 degrees. So there's only a 6 degrees difference here compared to the huge degree of difference down in the desert biome. Okay, so the temperature range here is only a 6 degree difference. It's wettest when it's hottest. So when its hottest months are these months of the year, January, February, March, and they are its wettest months of the year also. So we've got a relationship between heat and rainfall. Conversely, that's the type of language we might want to use when we're comparing opposites. Conversely, its coolest months are its driest months, and there's quite a range in its rainfall from about 260 mils up here in February, all the way down to about 20 mils in September. And that's a huge range of 240 mils. Now that's much difference to the range down here. Okay, so there we have some analyses of a tropical rainforest biome climate graph that happens to be in Cairns. Now let's look at a temperate forest biome and analyse its climate graph. And this one's in Sydney. So if we start with its rainfall, it has pretty consistent rainfall across the year compared to the others, which are peaks and troughs. Its highest rainfall is in February and in June, both receiving about 100 mils, whilst its driest month in September, which is spring, receives only about 50 mils. So we're 100 to 50. So that's a 50 mil range in rainfall, precipitation. Okay. Now that's a lot less than Cairns, but it's still more than a desert biome, which seems to make sense, doesn't it? Its temperature range. It's greater in a tropical. Its temperature range is greater than a top tropical rainforest, which is quite interesting. I think you probably would have expected a greater range in a tropical rainforest, maybe, but it is closer to the equator in a tropical rainforest, so the temperature is more stable. Whereas the further away from the equator that you go, the less stable the temperature becomes. So the temperature range is greater than the tropical rainforest, but less than the desert biome. You can see by the trend in this bend. Its hottest temperature, with 23 degrees, is in January, and its coolest is in July with 13. So you would subtract 13 from 23, and you end up with a temperature range of 10 degrees. Okay. So there you have it. There's some analysis of climate graphs which relate to a biome, which relate to a location. And you can do the same analysis that you've just heard here and use the terminology, the words that I've just used here. Things like conversely, when you're comparing and opposing, or temperature range to measure the highest to lowest in both temperature and in precipitation. And also trends in terms of whether it's going down or up to indicate its hemisphere, the location of whether the location is in the northern or southern hemisphere. And also the relationships between things. So what's the relationship between the temperature and the precipitation? So it's coolest in its driest. It's hottest in its wettest, that type of thing. Okay? Hope you enjoyed that and found that useful. Good luck with your own.